Next, we are going to talk about system development. In system development is nothing but developing and designing a software. Okay. In system development, we have two parts, SLDC and program development. SDLC is nothing but a system development lifecycle. So let's start about SDLC system. SDLC, we are going to talk about two methods. There are many methods, but we are going to talk about only two methods. One is waterfall. Waterfall method. Another one is an agile method. Okay. What is a waterfall method? Waterfall method is nothing but how you know, right, how the water flows, right, from top to bottom. Okay. Similarly, the process, the life cycle of it will go follow the top to bottom method. Okay. Here, the first stage will be system requirements. System requirements. This is the first stage. Okay. Next, we'll have analysis. Okay. Analysis. Okay, we'll have analysis. Next, we'll have after design, we will code. After coding, we will test. And then, this testing will provide to prod. Then we have maintenance. Okay. So here, how this flow goes is, first we'll gather the requirements. What are the requirements? The requirements are initially analyzed. Depending on the analysis, we can either go back to the system requirement and ask the clarification or any changes if we cannot do it in the system. Okay. Next, after analysis is done, we will design the system how it should work. Design is nothing but how the flow, normally the flow and how we want our system to act and react. See, normally, if for example you are see the e-commerce site, right? We have to first search for a product. Product has to be put into cart. From cart we can buy it. So that's one, right? That is a design overview design. If we found any flaws in the design, we can go back to analysis. Okay, while designing, if we find any flaw, we can go back to analysis, do analysis again, and see any other plan works for us. Okay, once the design is completed, we will start coding. Okay, so we will spend more time on analysis and design rather than coding. So these are the main things. Okay, once design everything is covered, coding is not going to be a difficult path. But even sometimes we see that while coding we face the difficulties which we thought we would able to do it, but we were not able to do it. While coding we get it. That time we again go back to drawing board. We can go back to design. Okay, once coding is done, the software is ready now. But whenever just coding is done is not the end of anything. We have to test it thoroughly. Okay, so that's where the testing goes. You all normally know that what happens in testing. In testing, we will find bugs, and those bugs will again be fixed and go back to code. Okay, then testing is done, everything is done. Then the product is made live. That is, it's put into production environment. Then it is not the end of a software. Then the maintenance starts. Okay, you have to provide the support for this. Any queries or any things, even after going to maintenance, we frequently find bugs in this. Okay, and that again will go back to testing. Okay, So normally one of the examples where we can say that maintenance in maintenance we say that some function, say a decimal point calculation was giving error. Okay, post production, then we go back testing. If we find the same bug, we will go back to coding again. Similarly, the cycle repeats. So you can see that it is like flowing, right, from top to bottom. So that is why it is called waterfall model. Okay. So this is about waterfall model. Here it's a step-by-step approach. Okay. You can here the it is a step-by-step. Each step it is individual steps are there. Okay. So there is nothing like here. The problem only is while coding we cannot change the requirements. Changes are not easily accomplished. Okay, I am coding, the change requirement comes, again it has to go to analysis, design and then code. We cannot directly include these code requirements in the code. Okay, that is the downfall of waterfall model. Okay, okay. So this waterfall model is best defined where the requirements are fixed. Okay, if your requirements keeps on changing, this is going to be a very costly because you are at the stage of coding. Consider as requirement change comes, it will again has to go to system requirements analysis, then design, then coding. So this whole process has to be repeated. So it's going to be a costly affair. So this model will actually work for when the requirements are fixed. Okay. Now we are going to move to the agile model. Agile model is the adaptive model. Okay. Here, here the constant feedback of users is taken. Okay, and each development happens in a sprint basis. Consider some teams have sprint of 2 weeks, where every 2 weeks, whatever the design is done, whatever system is produced, as will be given to the users to test it out. Check if they want to change the requirements there, then we can accomplish that. So here that kind of flexibility is there. Okay, and this is easy rollout. See this in this normally what happens is the small we take a small unit which we can go to production live, then we go live with that and then we make iterations over that. Okay, so here how this it goes as requirements. Once we gather the requirements, we go for design. Okay, then we go for development. Okay, post development we go for testing. Okay, once it is tested, it is deployed to live. Okay, now once it is deployed, what I can do, we can have an iteration added here. As I told you, the small chunks, right? These are the small chunks. Okay, so first requirements, then we are going to design, then we are going to develop, test, deploy. We can go to add on it. We can again go for requirements. Okay, we can design, develop, test, and deploy. So we can accomplish in a single sprint. That's why now majority of companies go through agile model, where they try to get out a product with a minimal configuration, and then over the time they will add on it. Okay, once everything is done, we say the product is completed. At the end, if there are no more iterations or anything, the product is completed. Okay, so this is an agile model. Here it is always going to be a continuous iterations, right? It's going to continuous circle. Here there is no like as waterfall model you can see. So here the good thing is you are you are dividing into small chunks. Okay, so you deployed it within a 2 weeks. You were all the things are done. You deployed it. Any new changes we can accomplish here, easily accomplish with requirements. So it is a faster way to go live. Okay, and that these are the main advantages of having agile model over waterfall model. Okay, waterfall model is good for where the requirements are stable. Agile model is good for where requirements are not uh, might be changing, keep on changing. So today's market the requirements keeps on changing because once it goes to production, there might be a different need for that. Some issues, some things might we get liked, or some things doesn't get liked, and this can be changed. Okay. Okay. Next, let's start about program development. Okay. In program development is nothing but a step-by-step guide to developing a program. Okay. So we saw in both other models, these are models to develop the program. Here we are going to talk about more in details in that those models. How these are so the main steps includes are understanding the problem, understand the problem. So here what problem we mean? We means requirement. Okay. Second is develop a solution. We develop the solution. Third, write the code. Fourth, testing. Okay, these are the four steps here. First, let's go talk about understanding the problem. Okay. So, understanding the problem is very important step. See, if you don't understand what is the exact requirements, then the software whatever the acting next is just it is not correct method, right? Correct. So here, if any problem happens, whatever you have done it here, it goes wasted. So you have to understand the problem. You may think sometimes in requirement analysis, you may think some of the things are silly questions, but still you ask the questions and get clarified. And one thing make sure is you don't assume anything. Okay, assumption leads to this one. So let's talk with an example out here. Consider your floor getting your floors. You are working for a flooring company, and normally in kitchen and bathrooms, antique skid tiles are installed, and normal other places normal tiles are installed. Okay, and you are given a chance to develop a software for them, calculating the price. Okay, so here you have to ask how the prices will be calculated. One of the main questions will be how the price will be calculated. But he will say some square foot. Okay, normally we do in square foots. In square foot, what is square foot? Also, you can ask the question. Even if square foot it says, you can ask the question that what is a square foot according to you? Okay, so those things, even if they are silly, please get it clarified. Now, coming to designing a solution, developing a solution. In developing a solution, there are three things. In developing a solution, we have three things: structure charts, second one is pseudo code, third one is flow chart. Okay, so developing a solution, we have three things: structured charts, pseudo codes, okay, and a flow chart. Structure structure charts is nothing like a blueprint of how what you are going to do. So consider the our example of flooring. Okay. Now what we have to check is how many total in a house, how many bathrooms are there, and how many kitchens are there. Okay. How many bedrooms, how many halls, everything. These are all the requirements. Correct. So that we are going to structurally hierarchy. In that we are going to differentiate if there are bathrooms, how many bathrooms. Okay. So basically we are providing two types of tiling, right? One is a normal tiling, one is anti-skid tiling. For normal tiling, we have to consider all the bedrooms and everything. Say there are two bedrooms, one hall, one dining area, okay, and consider they have two bathroom, one kitchen. So here totally will be four, five. Okay. Now the how we are going to structure it as a chart or chart shape. So what we can say is once we start a program, okay, first it will go get the inputs, correct? Take all these inputs. Now depending on the inputs, you have to calculate the price. Calculation first what we have to analyze, we have to analyze the number of bedrooms, the number of how many number of ends are required, and how many number of anti-skids are required. Normal tiles and anti-skids are tiles are required. Okay, so depending on that, for each in this one, you have to ask for each bedroom or each normal tile, we have to get the square root value for this. So consider a bedroom one here. So it has 100 square foot. Okay, and bedroom 2 has 100, hall has 100. Here, kitchen has 100, bathroom has 50. Okay, then here individually calculations will happen. Then once the calculation is done, we can get and we can display this. So here is a simple structure how the program will work. Okay, the same thing now we are going to write in a pseudocodes. What are pseudocodes? Pseudocodes are nothing but it is not an actual coding, but it's a small instruction. Pseudocodes. Okay, now we saw this, right? Okay, let me have it here and write it. Okay, so what is the first step? Here, what is prompt input from user. Okay, we are getting the input. Okay, so in the input from user, in that first input will be okay. What are the number of ends? The normal one. Second, prompt for static ones. Third, prompt to get the price for n prompt price for AS. Okay. Now we will do the calculations. Right. As we iterated here, same thing we are going to iterate in step 5 with number of AS is there. We are going to iterate to each inside each one. So take bathroom 1, bathroom 1 for AS. We are going to take a bathroom 1. Okay. Then we are going to multiply the for bathroom 1. What we are going to do? We are going to get the length and breadth to calculate the square field. Okay. Once the total length is what we will total is equal to whole total, whatever the whole total was there, plus length into breadth. Correct? Just a square feet. So we will iterate this how many times, how many items are there. The same thing for normal flooring. Okay. So this is kind of a code, but it's not an actual code. It's a pseudo code where we are just writing it what we are actually going to do. Okay. So once the pseudo code is done, we can go for flowcharts. What is the flowchart? Flowchart is nothing but we are giving a pseudo code and how our program will go. That's going to be a flowchart. Consider for this we are going to get a flowchart. First one thing is it's a start. Once we start it, we will have to read the inputs. Correct? Okay. Read the input for n. Then again read for AS. Okay, number of this one. Okay. So now depending on number of AS, we are going to loop, right? We are going to loop it. Okay. For bedroom 1, what we are going to do? We are going to check the square feet input, going to calculate, then we are going to back. Okay, until unless the number of rooms becomes 0. Okay, then we are going to display this result. So this is how the flowchart looks like, but we are going to discuss more on flowcharts in coming things. But this is a simple flowchart. What the flowchart is all. Okay, so post developing, right? This is about the developing the solution. You have written the pseudocode, you have the flowchart, what is happening, what's going to next, what is going to happen next. Next, you have to write the code. So you have designed, you have talked, you have done the flowchart, everything in writing the code, just converting those whatever is happening into code. Okay, you should make sure with error, we should write an error-free code. Okay, if the design is correct, whatever the design we did is correct, our code 99% of the time will be error free and without any bugs. Okay, so coding is done. Once the coding is done, we have to test it. Correct? In testing, there are two types of testing: black box, white box. Okay, so black box and white box. What's a black box? Black box is a testing done by a tester who doesn't understand anything about the system. He just only cares about the problem. That is, requirements. He only doesn't understand, he only states about the requirements. Okay, he reads the requirements and then tests it based on the requirements. Okay, here this stater what he will do, he will based on the requirements, he will do the test cases. Okay, and tests it accordingly. So as you said, it was someone who doesn't know the system, right? Here in white box, testing is not similarly who understands the system, who has all the knowledge of the system, what is happening there. Okay, maybe this is a dedicated testing member who has a knowledge on this, or a developer, okay, who is peer reviewing the things, what he has done. He has the knowledge of the system, knows the system. Okay, so here, as he doesn't understand black boxing, he doesn't understand the system, he's only going to look at requirements and do the testing. While in white box testing, he knows everything. Okay, as he knows everything, the testing will be more thorough with respect to the testing will be with respect to the system, existing system. So he will understand if any changes, anything which is going to impact. Okay, so here the task will be detailed. He has to write many test cases, many things, even a simple coding. Codes, he has to look into the codes and everything and analyze the system. So this will be a very tremendous, and this is a black box is nothing but a high level testing. Okay, based on requirement. This is basically done by the user, and this is basically done by the testing team. Okay, so this all covers in the introduction of computing, part of your first module. So that's it from this video. Okay, we'll come back with the next one. We'll see more about C. This was more about history and what are programs and everything. Okay, yeah. So I have prepared the notes. Okay, I will share with you guys, but I I will let you know in coming weeks how I can get the notes. Okay, thank you.